Okay, this is how to do that homework, the horizontally launched projectile homework. I'm going to do the first page first, the one that starts with horizontally launched projectiles, and then the next one I will do the back page with the projectiles launched at an angle. Alright, so on number 1, you have the Royal Gorge Bridge, and it has it is an unknown height, and it leaves with some velocity in the x. It goes out 45 meters, and it takes 8 seconds. And you have to find these two things. So what you're going to do first is we're going to find Vx. The only formula with Vx is Vx equals dx over t. So you do Vx equals 45 over 8, and you should get Vx is equal to 5.625 meters per second. Number 2, the second question rather, is how high is the bridge? Well, height is distance in the y, so dy is equal to 1/2 ay t squared plus biyt. And remember that if you kick something off horizontally, that the initial velocity in the y is 0, so you're left with dy is equal to 1/2 times -10 times 8 squared, which should give you negative 320 meters, meaning that it fell 320 meters, so the height of the building would be 320 meters, or the height of the bridge, 320 meters. Number 2, an Alaska rescue plane drops a care package off to a stranded party of explorers. The plane was traveling at 100 meters per second, and it was 50 meters off the ground. Okay, and we want to know what horizontal distance does the package travel before striking the ground. This is distance in the x. So, first thing, identify what we're looking for. We're looking for the distance in the x. So, we need dx equals Vx equals dx over t. So you should notice that we're missing t. So what we have to do is find t, and Vx, if you'll look, should be this, so 100 meters per second, and t, we're going to have to use this to find it. And so that's dy, and the only formula with dy is dy equals 1/2 ay t squared plus biyt. Remember, this is launched horizontally, so initial velocity in the y is 0, if it'll write, maybe. This is 0. There you go. And so we're left with negative 50, because it fell 50 meters, equals 1/2 times -10 times t squared, and you get t is equal to 3.16 seconds when you solve for this. So then I come back over here, and I plug in 3.16 seconds, and I end up with dx equals 316 meters. Right, number 3, a bomber a bomber is flying horizontally with a speed of 150 meters per second. It drops a bomb 1,550 meters in advance of its target. How high, or says what was the altitude of the plane? So altitude is a distance in the y. So we know we need to use dy equals 1/2 ay t squared plus biyt, and that's going to go to 0 because its initial velocity in y would be 0. But I need to find time, and usually I've been using time lately by doing dy, but look, I've got dx and I've got vx. So what could I use to find time? Well, I could use vx equals dx over t. So I get 150 equals 1550. Oh, those are terrible fives. 1550, still terrible 5. Oh well. Divided by t. And if you solve for t, you should get 10.33333 seconds. So 10.3 seconds, that's your time. And then I'm going to come back up here and plug this in. So dy is equal to 1/2 times -10 times 10.33 squared. And I should get dy is equal to 534 meters. Next one, number 4. A steel marble leaves a horizontal ramp at 4 meters per second. So, horizontal ramp, 4 meters per second. This is your Vx. You should know that your initial velocity in the y is 0. And it falls to the floor 1 meter below. So it's 1 meter. So we're looking for how long will it be in the air. And we're looking for, bad question mark. Man, I cannot do a question mark. There we go. And we're looking for how or where would you need to place the target. So we're looking for this right here. Where would that target need to be? Because the ball is going to come off and it's going to go doop, 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 down. Okay, so we need to find t and we need to find dx. So we're going to do time first. So you should know by now that if you have the distance in the y, you can use it to solve for time by doing 1 equals 1/2 times -10 times t squared plus 0 times t. So this is 0. 1 needs to be negative because it's falling. So we end up with 1 divided by 5 equals t squared, square root, and we end up getting 0.45 seconds is equal to t. Now to find dx. Well, Vx is equal to 4, so 4 is equal to dx over 4.45. Okay, so there you go. And you multiply that out, and you get dx is equal to 1.8 meters. Number 5. In physics lab, Melanie rolls a 10-gram marble down a ramp and off a table with a horizontal velocity of 1.2 meters per second. The marble falls in a cup that was placed 0.51 meters from the table's edge. How tall was the table? Well, in this case, we've got a little bit different than normal. We've got 1.2 here. We've got 0.51 here. And we want to find the height of the table, which is this. So to work out dy equals 1/2 ay t squared plus viy we need to find a time. How do we find a time? Well, we have a velocity in x, and we have a distance in the x. So what we're going to do is we are going to use vx equals dx over t to solve for time. So we would do 1.2 equals 0.51 over t. And if we do this, we get 0.425 seconds is equal to time. So then I'm going to come back up here and plug that in, and I'm going to get dy is equal to 1/2 times -10 times 0.425 squared plus 0 times 0.425, but that's going to go away, so I'm not going to even write it. So you should end up getting 0.903 meters. Okay, so you should get 0.903 meters for your answer, and that would be your distance in the y. Alright, so I'm going to pick up on the next video with talking about the 4 questions on the backside, okay?